about SQL injection. There is more to learn. For instance, second-order SQL injection attacks can happen when an attacker tries to get data put into your database, and that data later on gets used to construct SQL statements, and attacks can still become possible. I have some nice examples of this in the book. There's also blind SQL injection attacks, and the attacks that I've demonstrated thus far, the attacker needs to know a little something about the schema of the database in order to construct statements that can do successful attacks. And so blind SQL injection is a technique that attackers can use to, for instance, learn about the schema of your database by posing queries that will eventually reveal table names and column names and such things. Again, more examples of that in my book. So I've talked a little bit about SQL injection. SQL injection is a type of attack that can occur when input is not validated appropriately. There are other types of attacks in that category. Cross-site scripting, if you've heard of it, is another such type of attack. Not all. There's many types of vulnerabilities. There's many ways to categorize them. The second type of attack that I'm going to talk about is a cross-site-request-forgery attack. A cross-site-request-forgery can be considered to be a design error in a web application, and I'll tell you a little bit more about that. But there are also security vulnerabilities that can occur due to bad handling of boundary conditions, bad exception handling, improper access validation checks, etc. Before I start talking about cross-site request forgery, any questions? Okay, very good. I'm going to talk. So cross-site request forgery. The scenario that I would like you to have in mind is a scenario in which the user might be using one application, say Bank.com, and by the way, I'm just using Bank.com as a placeholder name. This is not really an attack against whoever the heck has Bank.com. But think of a scenario in which an attacker is logged into some legitimate good service that's at Bank.com, and the user logs into that service, say providing a username and password. The website checks the username and password. If the user is authentic, the website provides the user with a cookie that will be sent back by their browser on future requests to authenticate them. And in the scenario that I'm going to show you to illustrate how a cross-site request forgery attack works, the bad guy is going to lure the user to a site called evil.org and is going to be able to do bad things to the user. But the scenario you keep in mind is the user may have one browser window open to Bank.com and happens to have another browser window in which they get lured to evil.org, and the attacker is going to be able to do bad stuff. I'll show you an example. So in this example, we have Alice interacting with Bank.com. Alice might go to Bank.com and be asked to log in. So Alice requests a login.html page. What Bank.com sends back is a form that allows the user to log in. The user fills out the username and password. Say the username is victim and the password is FMD9032. And the web form might be constructed to make a call to a script on the server called auth. So basically, Alice's browser places an HTTP request for the auth script to be invoked and passes it the parameters, the username and password. Bank.com authenticates the user, determines it's a valid user, and sends Alice's browser a cookie with a session ID. The session ID is 40A4, etc. In this particular case. In a future request, Alice might then want to, say, check her bank balance. So Alice clicks some link in the site after having logged in and says, hey, I'd like to view a balance. And the browser automatically goes ahead and sends the cookie to Bank.com because that's how cookies work. They're supplied on future web requests when the user goes to Bank.com. And Bank.com looks at the session ID, determines it's a valid session ID, and sends back a message to Alice saying, your balance is $25,000. Maybe Alice is a student, and this is the beginning of the academic year, and of course, over the academic year, that might go to zero, but anyhow, for right now, Alice has $25,000 in her account. So what can go wrong? So let's say that there's this other website in the picture called evil.org, and Alice somehow gets lured to evil.org. So maybe she clicks a link in some message in a news group, or clicks on a link in an email that she received. And there's many ways to lure Alice to evil.org, but let's say Alice gets lured to evil.org. Let's look at what evil.org might want to do to Alice. So as before, Alice requests the login page, gets back a form. Alice authenticates, as before, provides the password, gets back a cookie after she's authenticated. Well, let's say after Alice has been authenticated to bank.com, say in one browser window, she gets lured to go to a page at evil.org in, say, another window. Well, Alice might request a document called evil.html from evil.org. That happens to be the document to which she's referred to. And evil.org sends back a web page that has a whole bunch of HTML on it. It might say nice things. It might get Alice to think she's at some good site or whatever it is. Part of the HTML in that page might be HTML that looks as follows. Image source equals http://bank.com/paybill, and then it passes some parameters. It passes the attacker's address. The address is 123 Evil Street, and amount is $10,000. So, Alice's browser gets back all this HTML, and of course, being a good browser, the browser wants to render the page for the user. So, I by the way, simplified this. This might not be perfectly technically accurate, but it's simplified for the clarity of explanation. Basically, Alice's browser needs to render this web page. And in order to render this web page, the document has told the browser, hey, there's this image at bank.com I want you to go get in order to render this page. And this happens all the time on the web, right? People link in images from other websites and whatnot. So the browser says, oh, okay, let me make a HTTP connection to evil.org. Let me make an HTTP connection to bank.com. I have to access the paybill script, so let me go ahead and do that. Let me provide the parameters that were requested. And when the browser makes that connection to bank.com, the browser notices, oh, the user is logged into bank.com, so to abide by the cookie spec, I should go ahead and send the cookie for the user to bank.com as well. So bank.com gets a request from Alice's browser that says, Alice wants to pay a bill, and the bill should be sent to 123 Evil Street, and the check should be made out in the amount of $10,000. Alice's browser goes ahead and passes the cookie. Bank.com receives the request and sees a valid session ID and sees a request from Alice to pay a bill to the attacker, and goes ahead and does so, because it looks like a completely authentic request. So it says, okay, payment sent, done. So Alice just got duped out of $10,000 due to this cross-site-request-forgery attack. Basically, evil.org was able to forge a request, and bank.com goes ahead and abides by it because Alice was logged in. So if you've ever received the advice of only interact with one website at a time, this is why one might want to do that. If bank.com is susceptible to a cross-site request forgery attack and happens to get and the user happens to get lured, it could be game over. So one interesting thing here is that for those of you that know about JavaScript and how the web works, you know that there's something called the same origin policy. And that basically means that when say, an executable script is served to a user, that script is only able to access resources at the website that script came from. In this case, the evil site wasn't able to read any of the information on the bank.com webpage, but it didn't matter, because what the attacker was able to do is make a write request to bank.com. It basically made a write request saying, here, please post this request and issue this bill payment. So write-only access can result in considerable damage. What kinds of sites need to worry about cross-site request forgery? Well, any application that really has any user information, right? So Facebook is clearly an example where where this attack could potentially be possible. In fact, there was an attack against MySpace back in 2005 where the bad guy constructed a site profile for himself